For the remainder of this module, we'll consider what happens when you take an acid or a base and let it react with water. In the next module, we'll let solutions of acids and bases react with each other. But for now, let's just think about what happens when you put an acid in water. Conceptually, this is a two-step process. First, we take a pure acid and dissolve it in water. Then, in a second step, it can react with the water it's dissolved in, and in doing so, will form the hydronium ion, H3O1+. We can write a balanced equation for this process. For now, we'll use the generic acid HA. We should get the same thing regardless of what A is. Notice that since HA is already dissolved, it is aqueous. The two products are also dissolved in water. Water itself is a liquid. Note that hydronium ion should always be a product of this type of reaction. We have written this as a reversible reaction, and as such, it has an equilibrium constant. The symbol for this equilibrium constant is K sub A. It is sometimes called the acid dissociation constant. The subscript A tells us this is for a specific type of reaction, in this case, an acid reacting with water. The expression for the acid dissociation constant is this. Ka equals the concentration of A1- times the concentration of hydronium divided by the concentration of HA. Note that water does not appear in the expression because solids and liquids do not appear in these expressions. Being an equilibrium constant, we're interested in whether it is greater or less than 1. As with any equilibrium, if the value of K is greater than 1, we would say that the reaction is extensive. Notice in this case, if HA is neutral, and we end up with mostly charged products, we would say that HA is a strong electrolyte. We'll use the same terminology, but call this type of acid a strong acid. If Ka is less than 1, the mixture is mostly reactants at equilibrium, and few ions would be produced. It would be a weak electrolyte, and we would call the acid a weak acid. We know that not every acid is neutral to begin with, so the electrolyte test doesn't help if the acid is charged. But we'll use the terms strong and weak to indicate the relative value of K. Think of it as how strongly the acid reacts with water.